Hello and welcome to my YouTube channel FiDiX. In this video, we will talk about the acceleration. Acceleration is the rate of change in velocity. Like velocity, it can be average or instantaneous. Average acceleration is given by the formula vector AV equals delta V over delta T, where delta V is the change in velocity and delta T is the corresponding duration. If the motion is rectilinear and occurring along the x-axis, the average algebraic acceleration along this axis is given by AX AV equals delta Vx, which is the change in algebraic value of the velocity or the change in the component of the velocity on the x-axis over the corresponding duration delta t. Thus, it is equal to Vx final minus Vx initial, all divided by delta t. In the International System of Units, the magnitude v, or even the algebraic value of the velocity Vx, are expressed in meters per second, the duration delta t in seconds, and the magnitude AV, or even the algebraic value of the acceleration AX AV, are expressed in meters per second squared. Example, a car moving along the x-axis in the positive direction at 20 meters per second accelerates during 2 seconds to continue in the same direction at 26 meters per second. Calculate its average acceleration. To answer this question, we start by writing the formula, then we replace each parameter by its value. Note that Vxi and Vxf are both positive since the car is moving in the positive direction. We get the average algebraic value AXAV of the acceleration. But in the question, they just asked to calculate the average acceleration without saying algebraic. Thus, the question is to find the magnitude of the acceleration. The magnitude of any vector along a certain axis is the absolute value of the algebraic value or component of this vector on that axis. So we can write AV equals absolute value of AX AV and get the answer AV equals 3 meters per second squared. In addition to the average acceleration, we will learn about the instantaneous acceleration, which is equal to the average acceleration when the duration is too small and is given by this formula that shows that the instantaneous acceleration is the derivative of the velocity. Note that delta t tends to 0 or approaches 0 in this formula means that the duration is too small. We already know that v equals vxi plus vyj, so its derivative a is equal to vx prime I plus vy prime j. We also know that any vector, for example a, can be written as its component on the x-axis ax multiplied by vector I plus its component on the y-axis ay multiplied by vector j. By comparing the last two equations, we can get ax equals vx prime and ay equals vy prime. And as for any other vector, the magnitude of the instantaneous acceleration is given by the square root of the sum of its squared components and is expressed in meters per second squared in the International System of Units. Example, the position vector of the center of mass g of a car in a frame of reference OIJ is given by r equals 1.5t squared plus 1 into I plus 2t squared plus 3t into j in the SI. Determine at any instant t its acceleration vector and magnitude. To solve the problem, we start by writing the formula v equals r prime and differentiate r with respect to time to get the instantaneous velocity. Then we apply the formula a equals v prime and differentiate v with respect to time to get the instantaneous acceleration. A equals 3i plus 4j. For the magnitude of the acceleration, we apply the formula a equals square root of ax squared plus ay squared. Calculate and get the answer a equals 5 meters per second squared. Thanks for watching. Don't forget to check out my other videos and subscribe to my channel if you enjoy the content.